Swayam Prabha. Digital India. Educated India.
Now that we have derived expressions relating the strains and the displacement field, let us go back to our earlier example, where we qualitatively demonstrated that if you give me displacement field, we can tell looking at the figure and so on. Now, we can quantitatively evaluate them, because what you all need is displacement field. Okay. So, let us do that. Simple calculus is required to do that. We are given the displacement field. So, once again we will do left hand side and right hand side separately. For the left hand side case, this was the displacement field and we had 2 alpha minus beta x. These were the conclusions which we arrived there. Okay. No normal strain, no shear strain, there was rotation. Just looking at the diagram, okay, figure initial state and final state. Now, let us evaluate that. The normal strain is epsilon xx is equal to dou ux by dou x, and in this particular case the x displacement is not a function of x. You do not have x on the right hand side, which means that if you partially differentiate with respect to x, you get 0. We said no, we have now quantitatively shown that it is indeed 0. Now, what about y direction? Dou uy by dou y. You look at this expression for the y displacement, there is no y there, and then if you differentiate with respect to y, you get 0. Okay. So, same conclusion as we have arrived earlier, but now quantitatively. Now, what about shear strain? Dou uy by dou x, differentiate uy with respect to x, you get minus beta, and then we had dou ux by dou y. So, differentiate this with respect to y, you get plus beta, giving you 0. So, now the shear strain is also 0, that is what we inferred from the figure, initial state and the final state of the figures, but now we have quantitatively shown that it is 0. Okay. In fact, the minus sign here has been chosen so that you do not have any shear strain in this particular case. Now, let us evaluate the rotation. Omega xy is half of the earlier same derivatives with the minus sign. We also discussed how to remember that. So, now it is half minus beta, but now it is minus beta here, earlier it was plus beta, it just got cancelled, but now it is half dou uy by dou x, differentiating this expression with respect to x gives you minus beta, and then differentiating this expression with respect to y gives you beta, but you have additional minus sign. So, if you evaluate, you get minus beta. That is what we said, rotation is yes, but what is the difference now? Quantitatively we well evaluated that it is minus beta. For example, beta was 0.05, so omega xy is equal to minus 0.05. Now, what else can we infer? We assigned a positive value for anticlockwise rotation, negative for clockwise rotation. Now, we have got a negative value for rotation, which means that the element should have rotated clockwise, and that is what we see here. Okay. So, qualitatively we can say that there is rotation, element has rotated clockwise, but now we are quantitatively saying it is minus beta. Okay. That is the difference from the earlier discussion and the present discussion. Okay. Now, just let us repeat this for the right hand side case. We said that the displacement field is almost same with a small change, minus beta to plus beta on the for the uy vertical displacement. Let us see what is the effect. We have already seen the effect, no normal strain, there was shear strain and there was no rotation. Okay, that we can infer from the figure itself. Now, let us quantitatively evaluate that. Epsilon xx is dou ux by dou x, same expression for ux, obviously only sign of beta has changed. Okay. So, differentiate ux with respect to x, it is 0, uy with respect to y, it is 0, no normal strain. What about shear strain now? Dou uy by dou x. So, differentiate this expression with respect to x. Now, you get plus beta. Remember, earlier it was minus beta, now it is plus beta. What about second expression? You differentiate ux with respect to y, of course, like earlier beta. Now, they add up, earlier they cancelled, now they add up, giving us 2 beta, which means there is shear strain. That is what we conclude from the figure as well. Now, what about rotation? Omega xy, half of the earlier two derivatives with a negative sign. So, half of beta minus beta cancels out, giving us no rotation. Okay. Same conclusions as we have arrived qualitatively, but now quantitatively we are saying yes, that there is shear strain, but no normal strain, no rotation. One more point, we said the shear strain is positive when it becomes acute, okay, it becomes acute angle. That is what we are seeing. Earlier we had at right angles to each other, and it has become an acute angle, and it should result in a positive shear strain, and we have got that as 2 beta. Let us say beta is 0.05, we have got that as positive. So, whatever qualitatively you have seen based on the displacements have now been related to displacement gradients, and we have evaluated them quantitatively. Okay. Another example on relating displacement to strains. Okay. Look at the title of the slide. Title says experimental measurement of strains and rotation. Okay. That has to be kept in mind. We will discuss about the significance of that, but right now what is the significance? You have a plate, and then you mark some points, a force is applied, and then the points get displaced, and we know the coordinates. We have, this example is not new to us, we have already seen when we discussed about 2 dimensional displacement field, displacement gradient. And then of course, initial coordinates are given, the final coordinates are given. Okay. And the difference between the earlier example and this example is that earlier example we are given a displacement field as an expression, look little more mathematical. Now, the salient feature of this example is that we are given the coordinates, which means that they are measurable. You have a plate, and then there are some initial state, let us say you applied some force, something happened, some change in angle or length, etc., and then you can find out the new coordinates. That is why the title says experimental measurement of strains and rotation based on the coordinates. Okay. So, let us quickly read. Figure shows the coordinates of a rectangular plate ABCD. The coordinates are given, okay, before deformation. If after undergoing 2 dimensional strains, okay, the new coordinates are also given. Okay. Find the normal strains epsilon xx, epsilon yy. This is new. Okay. Earlier the question was find the displacement gradients. Now the question is find the normal strains epsilon xx, epsilon yy, shear strain gamma xy, and rigid body rotation omega xy. Okay. Now, earlier also we in another example we made this assumption. The assumption for this particular case is that if you look at the diagram, the rectangle becomes a parallelogram. Okay. And remember, we discussed earlier that lines parallel to the axis remain parallel. If you draw according to this configuration, they are something like this. Okay. So, they remain parallel, which means that the strains are all uniform throughout.